Hello all, welcome to the video sessions on Arduino and robotics. So before proceeding to Arduino, you should have minimum knowledge on embedded systems and basics of electronics and also some other basic stuff. So first I would like to start with embedded systems. Generally, what is an embedded system? Embedded system is a combination of hardware and a software which is dedicated to do a particular task or a job. Say for example, if you take your mobile phone, it's basically an embedded system because it is a hardware where one software like Android or some other operating system is going to run that particular hardware. So that mobile phone is called as embedded system. So not only mobile phone, you can observe your digital watch. It is also one type of embedded system where a small code or program is going to run in the watch, which help the processor to project the time on the display. So embedded systems can found almost all devices which are in our home. We can see embedded system from kitchenware to space. Here some of the examples of embedded systems. You can see a television. It is a one type of embedded system where it contains a processor or a controller which is going to take signals from the remote and it is going to change the channel. So it is doing one task, that is it is monitoring the signals from the remote and also trying to change the channel or increase or decreasing the volume. Similarly, if you observe washing machine, what exactly it is doing, it is going to calculate the weight of the clothes and also it helps the motor to wash the clothes. Similarly, if you take mp3 player and also a setup box and cell phone will have embedded systems. So here we are having some more examples which contains embedded systems. So first one is AC, that is air conditioner. So what is the main aim of the AC? It simply monitor the room temperature and it try to decrease or decrease the room temperature. So if you observe in the AC, there will be a small display and also one temperature sensor which is going to monitor the room temperature, and the sensor data is given to the controller or a processor present in the air conditioner. Finally, the controller is trying to push the data to the screen. Ultimately, the compressor present in the AC will be controlled by the controller or a processor. Similarly, if you take advanced micro ovens, they can control the oven temperature by using the temperature sensor similar to the AC. And also a geyser. If you observe the geyser, latest geyser, they are having embedded systems. Means the geyser temperature can be controlled or it can be monitored by using a mobile phone or some other displays. So what is the significance of the embedded systems, or why we should use embedded systems? Due to their small size and low cost, we should use embedded systems. If you observe the embedded systems, we can found from kitchenware to spacecraft. Now we are going to see some of the applications of embedded systems. First, I would like to start with medical. So if you observe medical side, you can find embedded systems like ECG recorder, blood cell recorder. So when you go to hospital and when you observe, there you can find some of the devices which are going to monitor the heart rate of the patient, or they are going to record the blood cells present in the body. So all these things contains embedded systems. Coming to communication side, embedded systems are playing major role. If you observe your cellular phones and cable TV terminals, all these are made up of using embedded systems. And also we can find these embedded systems in our computer also. If you take your computer, generally it's also a one type of embedded system where everything is made up of using a processor or some other stuff which is present in embedded systems. Now Embedded systems are also playing major role in industrial side. If you observe in industries or factories, some industries have to work with motors where the speed of the motor can be controlled automatically by using automated systems which are made by embedded systems. So here we are having some of the applications in industrial side where robotic systems can made by using embedded systems. CNC machine controllers, closed loop engine controllers means they will have a feedback from the shaft of the motor. And coming to research side, embedded systems are also playing major role. If you see in military side, military and space, you can find embedded systems means in military mainly embedded systems are used to detect the bombs and target the enemies, and also in space side every satellite is made up of using embedded systems. Not only military and space, embedded systems are also helpful in agriculture side where these embedded systems can promote a smart farming. And also I already told you that embedded systems can found in almost every home appliance, that is consumer electronics. So when the embedded systems had started its evolution, actually embedded systems are coming from older days, but many people don't know because embedded system contains a processor to which we have to attach input output devices by using some other extra peripherals. Due to this thing, many people don't know about embedded systems. But coming to advanced embedded systems, microprocessors are overcome by microcontrollers where we can directly attach input output devices. So coming to the components of embedded systems, what is the major component present in the embedded system? That is a CPU and a memory and input output ports. So generally when we talk about CPU is central processing unit where it is going to process the data coming from the input device, and finally it will generate specific output for the output device. So coming to CPU, there are few types of CPUs. One is microprocessor and microcontroller. So when we talk about microcontroller is a small device where it can do a specific task or specific job for infinite time. So where exactly we can find these microcontrollers? If you open your television, you can find a microcontroller which is connected to some sensor. That sensor is going to receive the signals from the TV remote, and finally it will send that particular data to the microcontroller, and it will process the data and generate specific output for the television. Not only in television, if you observe in ACs, we can find microcontrollers. So here when we talk about microcontrollers, they are intended for only specific tasks and also a single task. At a time, only one program is going to run in the microcontroller. When we see microprocessors, it can execute multiple applications. So the best example for the microprocessors is your laptop or a personal computer where multiple applications are going to execute at the same time. Say for example, you can browse internet at the same time, you can chat with your friends, listen music, all these things can happen at the same time because of using microprocessor. But coming to microcontroller, application is specific like television and washing machine. Say for example, television can't wash the clothes, and coming to washing machine, it is not going to change the channels of the television. So every device has a specific application. Now what is the other major thing present in the embedded system? That is memory, in which operating system is present. So why we require operating system? According to our application, we have to select whether we have to use operating system or not. Say for example, if you take your AC, it doesn't require operating system because it is doing only one task. So for single task, we require only one single program where it should execute continuously in the processor or a controller. So if you are making a project with multiple applications, at that time you have to choose an operating system and a microprocessor system. Now this is the basic architecture of embedded system. As you can see, application software and hardware are divided by operating system. Means here operating system is acting as mediator between hardware and application software. So operating system helps the user to access the hardware by writing a program in application software. Now we will see other some of the other components present in the embedded systems. One is input output device and communication interfaces and application specific circuitry. We will see one by one. So when we talk about memory, there are mainly two types of memories. One is primary and one is secondary. Primary in sense it's a temporary memory where the data which have to execute is stored temporarily in its memory. Coming to secondary, data will store permanently in that memory. So say for example you are making a small application where you have written a program. That program should store permanently in the memory so that we can access that program many times. So for that purpose we have to use secondary storage devices like flash memory and EEPROM. So to speed up the execution of the data we should use temporary memories like RAM. Coming to input and output devices, when we see the input and output devices of computer, we know that keyboard, mouse are input devices and monitor are the output device. Coming to embedded systems, the input and output devices are LEDs, maybe a motors, a displays. So LED is considered as output because it is giving light as output. Similarly, if you take a motor is an output device because it is going to give a mechanical torque as output, so it is considered as output device. If you take a switch, it is input device because we are going to give something from the switch. That means we are going to input the data by using the switches. Similarly, sensors are fall under input device category because sensor is going to monitor something from the environment and finally it is going to give the data as input to the controller. So here you can see the block diagram of embedded system where input is given to the CPU and after processing the data it is going to generate specific output. So your program is going to store in the flash or RAM. RAM is useful to speed up the execution of the data, and also if you want to connect some other devices or some other controllers with your embedded system, you can use communication interfaces where you can connect multiple devices by using different communication protocols. So as we already discussed that there are mainly two types. One is two types of processors. One is microprocessor and microcontroller. So both controller and processor will have common in CPU, but coming to microprocessor, it will only contain CPU. Other devices we have to connect to it externally. But coming to microcontroller, all the things like RAM, ROM, and some other on-chip peripherals are inbuilt to it. Means all the things are fabricated with one silicon chip and we are calling that silicon chip as microcontroller. So If you observe microprocessor, it only contain arithmetic logic unit and control unit and memory unit. But coming to controller, along with the CPU, that means ALU, CU and memory unit, along with these three things, microcontroller contains RAM, ROM and some other peripherals like serial communication peripheral, CAN controller, etc. And also coming to microprocessor, it has flexibility to increase or decrease the size of memory. Say for example, if you open your CPU cabinet, there is a motherboard to which a processor is attached. So all the devices like hard disk, RAM and other input output devices are connected externally to the microprocessor. So there is a flexibility to change the size of the secondary storage or a primary storage. But coming to microcontroller, there is no flexibility. Once the manufacturer has done with the microcontroller, we cannot change the size of the memory in microcontroller. So that's why lots of microcontrollers are available in the market. According to our application, we have to select particular microcontroller. So microcontroller contains CPU, memories like RAM, ROM, input output ports where we can connect our motor, LEDs, etc. And also timers and counters where they can generate a time delays, a specific time delays, analog to digital converter. So here analog to digital converter is nothing but a converter which is going to convert the analog data into digital. So why should we require this analog to digital converter in microcontroller? If you want to measure the temperature of the room, you have to use a temperature sensor. Actually every if you take temperature, it's analog in nature where it is going to vary time by time. So this varying temperature will not understand by the microcontroller. So at this time, this varying voltage, this varying temperature voltage should convert into digital so that a controller can understand that. For that purpose we are going to use analog to digital converters. And also it is having onboard reset button, and some microcontrollers will have flexibility to debug the program. So what are the features of embedded systems? Coming to the features, embedded systems have a limited resources, means limited amount of RAM, limited amount of ROM, means 1 KB of RAM, 8 KB of ROM. So according to our application, we have to select particular controller. Say for example, if you are making a big project where your program size is some 40 KB, you have to select the controller which have a flash memory more than 40 KB. Similarly, RAM. So coming to some other features, embedded systems have to work against some deadlines, means some specific jobs has to be completed within the specific time, or otherwise some distractions may take place. And embedded systems consume low power, and sometimes embedded systems have to work in extreme environmental conditions like high temperature and humidity regions. Now we are going to see the classification of embedded systems. So mainly embedded systems are classified into four types. One is standalone embedded systems, real-time embedded systems, network information appliances and mobile devices. So first we will see the standalone embedded systems. So when we see standalone embedded systems, these are the systems where they can do a specific task or only single task. They will take the input and they will generate a specific output. So the examples of standalone embedded systems are LCD displays, LED displays, and also automobiles, consumer electronics items like television, air conditioner, etc. So these are fall under standalone embedded systems. Coming to real-time embedded systems, real-time embedded systems are classified into two types. One is hard real-time embedded system and second one is soft real-time embedded system. So coming to hard real-time embedded systems, these embedded systems will have a particular timing deadline. If it crosses the timing deadline, destruction may take place. So the best example for hard real-time embedded system is aeroplanes. When landing, at the time of landing of aeroplanes, the tires should be open at particular time. If they didn't open at that particular time, destruction may take place. So at this time, to avoid these type of destructions, we have to use real-time embedded systems, that is hard real-time embedded systems. But coming to soft real-time embedded systems, they should not follow any timing deadline. Means if you observe your TV, you have given some command by using your TV remote, the channel or volume are changed after some 2 or 3 seconds. Nothing will happen for this. So these kind of embedded systems are called soft real-time embedded systems. So coming to networked information appliances, it is also one type of embedded systems where embedded systems are going to connect with internet by using local area network or some other Wi-Fi, and they try to share the data with the other system which is already connected to the internet. So for this purpose, the communication can be happened by using a LAN or Wi-Fi. So if you take a web camera, when web camera is connected to internet, we can access the data of the web camera from anywhere in the world. Hence, it's also one type of embedded system where the web camera is going to push the data to the cloud. Finally, we are going to access the cloud using some addresses and we will use the data. So one more small example or application of these network interface appliances is the door lock of your home can be a small embedded system where a small server is going to run on it. So there is one camera attached to the door of your room and it is continuously going to monitor the outside of the room, and finally it will take the snaps of the region and it will push the data to your computer. Finally you can see who exactly present outside the door. So we can also see some weather monitoring systems where many people can access the weather from their mobiles or desktops. Here you can see a weather monitoring system is connected to internet and some other desktop computer is going to connect to the internet and trying to access the weather parameters. Not only one desktop computer, we can access multiple desktops. We can access from multiple desktops. So coming to programming embedded systems, we can use different types of programming languages to program embedded systems. So assembly language is best to program embedded systems, but the syntaxes of the assembly language is difficult when compared to high level languages like C. So about 45% of the embedded systems are programmed by using C language. Now we are going to see some of the communication interfaces. Say for example, you have your microcontroller and your microcontroller have to share the data with the PC or some other microcontroller. At this time, you should use some of the communication protocols like serial communication or synchronous serial communication. So in serial communication, we are going to send the data by using RS-232 hardware or some other hardwares we are having RS-422 and 485. So by using these things, we can send the data from one microcontroller to another microcontroller. So coming to serial communications, we are having some three types of serial communications. One is simplex serial communication, half duplex serial communication, and full duplex serial communication. Coming to simplex serial communication, one way of transferring the data can be happened means one microcontroller can send data to other microcontroller. So here only one way. Coming to half duplex serial communication, receiving and transmitting is possible, but at a time it is not possible to receive and transmit the data. And third type of serial communication is full duplex serial communication, where we can transmit and receive the data serially simultaneously. Coming to other advanced serial communications, that is synchronous serial communications, we can use I2C, which is inter-integrated communication, I2C, I square C, or so it is a one type of advanced serial communication where multiple controllers are going to interact with each other using one I2C bus. Coming to JTAG, it's mainly helpful to debug the hardware of the embedded system, and SPI, serial peripheral interface, where multiple devices are going to communicate with each other. So one of the most popular type of communication is USB, universal serial bus, where we can transmit the data by using this USB. So if you want to transmit the data to other network, you should use internet connection. For that purpose, we require Ethernet or CAN or some other networks. So coming to Ethernet, your controller is connected with the Ethernet, and it will try to share the data with the internet. And other in the other end of the internet, one more controller is going to connect to the same internet, and finally it will take the data from first controller. So now we are going to make a small embedded system. That means we are going to design a small embedded system which will monitor the temperature and finally displays on one display. For that purpose, we have to select a particular microcontroller. I have already told you that there are different types of microcontrollers are available. Say here I'm going to monitor the temperature, so here my application is specific. For specific applications, we should use microcontrollers. For multiple applications or many applications, we should go with microprocessor. Here my application is specific. For that purpose, I have to use a microcontroller. So coming to microcontrollers, there are thousands of controllers available in the market. So you can see microcontrollers mainly categorized with bits, memory and instruction set, and memory architecture. Coming to bits, there are 8-bit microcontroller, 16-bit microcontroller, and 32-bit microcontroller. So what is this 8, 16, and 32? If you take 8-bit microcontroller, it can process or access the data of maximum 8 bits. Coming to 16 bits, it can process the data of maximum 16 bits limit. Similarly, 32. Coming to 8-bit microcontroller, every register present in the microcontroller will have 8 bits of size. Similarly, 16 and 32. Coming to memories, some microcontrollers will have inbuilt memory and some other will not have any memories. We have to connect external memory for it. So we have to choose a controller which will have inbuilt memory and also instruction set. So this is one of the important parameter. Actually there are two types of instruction sets are available. One is RISC, another one is CISC. RISC means reduced instruction set computer, and CISC complex instruction set computer. So coming to RISC, we can easily program a controller or an embedded system. So here the instructions are very easy to understand. If you take CISC, the instructions will become complex. So the best example for RISC is if you 8051 microcontroller or some other AVR microcontrollers, they all prepared by using RISC architecture. So programming these controllers is very easy. If you take CISC, the example is Intel. Intel manufacture their microcontrollers or microprocessors by CISC architecture, means instructions will increase. Say for example, I have done one project in RISC microcontroller. It has taken some 10 lines of program. The same program will take some 20 lines in CISC microcontrollers. Similarly, you should also consider memory architecture. One is Harvard and another one is Princeton. Harvard in sense code memory and program memory are different, so that the execution will become faster. Coming to Princeton, code and data memory are combined, so it will take some time to take the data from the memory. So here I am going to select some 8-bit microcontroller in which inbuilt memory is, and also I am selecting RISC based instruction set microcontroller with Harvard architecture. So this is the basic example where I am going to take data from the sensor, and after processing the data I am going to put the data on the display. Say for example, here I am using a temperature sensor. The temperature sensor is going to monitor the temperature. After getting the temperature, it will give to ADC, analog to digital converter, where this analog data of the temperature sensor is converted into digital. So this digital can be easily understood by the processor or a controller. After that, after processing the data, it is again converted into DAC, and finally DAC in sense digital to analog converter, and finally it is going to send to output device in sense it may be a motor or some fan or some other LCD display. Okay. Okay.